All right, hey guys, we are starting to look here at chapter 6, and this idea we're looking here today at 6.1, this idea of roots and radical expressions. All right, what exactly are those? So, first of all, when we talk about roots, all right, if we have real numbers A and B can be whatever you want, and n is some positive integer 1, 2, 3, 4, so on and so forth. If a to the n power equals b, then A is called an nth root of B. All right. So let's just, to fill in some numbers here. If A is 5 and N is 4, all right. And that would be 625, I think. Okay. So we say that 5 is a fifth root or a fourth root of 625. If 5 to the fourth power equals 625, then 5 is what's called a fourth root of 625. So this idea of radical expressions, roots and radical expressions, kind of the inverse of exponents here. All right. Now, a couple things here. If n is odd, all right. So if this is an odd exponent, then there is one real nth root of b. All right. And it's written as the nth root of b. Okay. If n is even, all right, and b is positive, all right, so we're looking at this situation here, all right. Let's just come back to this. So if n is odd, let's do an odd one. So we'll make a 3, and we'll make let's make n 5 here. All right, we want n to be odd, and 3 to the fifth power, I think, is 243. All right, 3 times 3 times 3 times 3. Check me out on that, but I think I'm right. So the fifth root, all right, of 243, there is one and only one answer to that. There is, what times itself 5 times gives you 243. There's one and only one answer to that. Okay, so if this is odd, this expression here, regardless of what this number is, as long as it's odd, will always have only one answer. All right. Now, if n is even, and b is positive, all right. So let's focus more on this part of it here. All right. Let's go here. All right, here. N was even and b is positive. Okay. There's really two nth roots. All right. The positive root is called the principal root, and its symbol is written like this. All right, the fourth root of 625. Or if we look at this, -5 is also a possibility, because if I do -5 to the fourth power, I also get 625. So this expression here really has two roots, okay, a positive one and a negative one. But the positive one, that's what your calculator is going to give you. That's what we're typically going to talk about. That's the principal square root. Okay, if b is negative, all right, so let's look at this expression. N is even and b is negative. So let's make n -4, or I'm sorry, not n is even, and b is negative. All right, let's do this one. All right, so the fourth root of -16, there are no real roots to this, okay, because I can't multiply anything 4 times and get -16. All right, if I try -2 times itself 4 times, I'm always going to get a positive 16. This is where we might get into imaginary numbers, but for this, we're just talking about real roots. There's no real number that I can multiply by itself 4 times and ever get a negative. All right. Okay. So if n is odd, there's only one. If n is even and that number underneath is a positive, then there's really two. One, though, we call the principal. The other one, though, we have to understand is out there. But if b is negative, if this is an even number and the number underneath that radical is a negative, there are no real roots. So now you can use a radical sign, a square root, or not a square root sign, but a radical sign. Let me call it what it is to indicate a root. The number under the radical sign is called the radicand. Let's get some terminology down here. And the little number above, and I'll show you an example here, is called the index. All right. So if we go, let's just go back to the one we just did, the fourth root of 625. This is the radicand. That is called the index. All right. So the radicand is the number underneath this, the radical symbol. I need to stop saying square root because they're not all square roots. This is a fourth root. Okay. If let's just talk about that. Let's just go there. All right. So if I look at that, the square root of 36. This is the radicand. What's the index? Well, there's nothing there, but there's always an assumed. If they don't write anything in, then there's an assumed 2, but we've never written that in. All right, but if there's nothing written there, then that's assumed to be a 2. All right, but the radicand is the number underneath the radical symbol, and the index is the number, the degree of the root. All right. So, when we want to find all the real, so if it says find all the real roots, so find all the fourth roots. So the fourth root of 1, all right? So again, now here we're talking, if this is even and this is positive, there are 2 answers out there, all right? The principal one would be 1, okay? Because 1 times 1, obviously, 1 times 1 times 1, 4 times, would give you 1, all right? And that's the principal, okay? But -1 is also a root of that, because if I do -1 times itself 4 times, I also get +1. So again, we've got two roots there, all right? If I do the fourth root of negative, I believe that's 1/10,000th. Well, if I've got an even root and a negative underneath, there are no no real roots there. All right. And just if I want to do the fourth root of a fraction, I can do that by doing the individual fourth root of each numerator and denominator. Okay. So here I would get, again, the fourth root of 16. What times itself 4 times gives you 16. 2, and we'll look at how to use your calculator to figure that out if you can't get that. And what times itself is 81, 2/3. But then again, we're also going to have -2/3 as well as being one of those roots. All right, so if we're talking about an even root there, you really have 2 roots, okay, if we have an even index. All right, but there is a possibility for none. Now, the fifth root, all right, so the fifth root of 0, if this is odd, we've got 1 answer. So what times itself 5 times gives you 0? That's just 0. Okay. The fifth root of -1. Now normally back up here when that was even, we didn't have that. But here, what times itself 5 times would give you -1? Actually -1. All right. If you multiply -1 times itself 5 times, you get -1. And then the fifth root of 32. What times itself 5 times gives you 32? It's actually 2. Okay, let's just talk about how to get those. We might as well let's look at that real quick, just because some of those you're going to get to know. But if I want to know, for example, the fifth root of 32, okay, I believe it's under my math button. Okay, yeah. So if I hit all right, so if I hit my math button. Yeah, where'd my math button go? There it is. All right, so if I have my math button, you notice number 5 down there is the xth root. All right, so before I get into this, I got to kind of plan ahead. If I want to find the fifth root, I type in 5, I hit math, and then I go down to number 5 there, and so I can either type in 5 or scroll down and hit enter, and then I can type in 32. So there's the fifth root of 32. All right, and that will give you that answer. So that math button there is there. Now you notice under the math button, you can use that for any index you want. Square root is actually right there, so you don't have to go to that math button, but it would work. All right, if I did the square root of 16, let's say, for example, all right, it's going to give me the square root of 16, but I could also use just that button there. All right, also under the math button, you see there is a cube root. All right, you could use either one of these by typing in the 3 first and using 5, or just going right to number 4 and finding the cube root of whatever you want. Okay. Um, to find the real, to find roots now, okay, we can we can do this. So the cube root of -8. Now again, I can either type in 3 or choice number 4 is the cube root. So let's hit that. All right. So notice it's got, I know it's hard to see with the smudge there, but it's got the cube root of -8. And again, make sure you use the white negative button, okay, not the subtraction button. And the cube root of -8 is -2. All right. And again, that's an odd number, so I only have to give one answer. The square root of 400. Again, I could hit 2 and math and all that, but again, I've got my square root symbol right there. So square root of 400. All right. I get the principal of 2/10. I'm sorry. Okay. And here we're only looking for the principal square roots. All right, so that should have said the principal square root of 400 is 2/10. The fourth root of -1. Well, I'm not even going to type that in my calculator. If I've got an even index there and a negative radicand, I know there are none here. All right, and now the square root of -2 squared. All right, so again, I can the square root, and I'm going to put that just like I see it. All right, -2 in parentheses. And then I'm going to hit my squared button. Okay, so the square root of -2 squared is 2. All right, and again, kind of go in order of operations here. That'd be I got to do what's underneath there first. I got to do the square root of 4, and then the square root of 4 is 2. All right. Okay, so you can also use your calculator to evaluate these as well. All right. Now we're going to skip, these would have been done in class, but since we're not in class, we're going to go down here. So when we talk about the nth root of nth powers, all right, what is the nth root of a to the n power? So in other words, what is the square root of x squared? Okay, what is the cube root of x cubed? All right, it seems pretty simple that the square root of x squared would just be x, and the square root of x cubed would just be x, or the cube root of x cubed would just be x. But real quickly, if if n is odd, then yes, this answer is exactly right. Okay, the cube root of x cubed is x. But if n is even, the answer here is actually the absolute value of x. All right, and I'm going to take you back to this. Okay. Because the square root of -2 squared was not -2, it was the absolute value of -2. All right. So if we have a variable there, the square root of x squared is not just x, it's the absolute value of x. All right. Now that only happens if n is even. If n is odd, if that index is odd, it's exactly what you think it would be. All right. So here, if I want to do the square root of 16x to the 8th, what I like to do is just break this up. It's the square root of 16 and the square root of x to the 8th. Well, the square root of 16 is just 4. Okay. Now again, technically these are even, so I would want to do the square root of 4, but the square root of 4 is just 4. Now, what is the square root of x to the 8th? Well, I can do 8 divided by 2, all right, and that is x to the 4th. Because if you look, we're saying what times itself 2 times would give you x squared? Well, x to the 4th times x to the 4th, because we add those exponents together, all right, so x to the 4th times x to the 4th would be x to the 8th. So the square root of x to the 8th is x to the 4th. Now again, I should have absolute value symbols around that. But if we think about it, anything to the 4th power is always going to be positive anyway, so I technically don't need those. Okay. Now here, I'm going to break this up, the cube root of a to the 6th and the cube root of b to the 12th. So here I do 6 divided by 3, so that's a squared, and 12 divided by 3, that's b to the 4th. And again, this was odd, so I don't need to worry about any absolute values. If this is an odd number, the answer is exactly what I would think. And here, the 4th root of x to the 8th and the 4th, so this would be the 4th root of x to the 8th and the 4th root of y to the 12th. So again, 8 divided by 4, that's x squared. And I probably should have absolute values around that, but x squared, no matter what x is always going to be positive, so the absolute values really are kind of pointless. And here I would get 12 divided by 4, I would get y cubed. Now there, I do need those absolute value symbols, because y cubed, depending on what y is, could be positive or negative. Okay, but this answer, I always want it to be I always want it to be positive. Okay, so just notice here when those absolute value symbols come into play. All right, they come into play if you are talking about an even index. Okay, and again, there's some questions on the back there that we're not going to get to, because we would have done those in class. But so here is your homework out of the book. Make sure you get those shared on Flipgrid. Share any questions you have with me, and I look forward to hearing from you. Take care, guys.